英文对。那好，我们这一场会来会请嘉俊这边来替我们介绍一下关于这个地端网络的跟 Kubernetes 相关因为大家知道，如果做 Kubernetes 来讲，哪一部分大概是最难的？有概念？其实我跟大家讲，如果你网络看得懂，可以一次吃好几家，这个可以吃好几年的饭，就网络很难哦，这个很难。英文入门。那这个 BGP 现行应该是整个全世界目前在 Cloud 世界来讲会很常通用的一种 protocol。我蛮强烈大家建议有机会的话可以多了解一下这个通讯协议。那我们掌声欢迎嘉俊。
Hi, good afternoon, everyone, and welcome to my presentation. Today, I'm honored to be here to share my experience. Many of you may be quite familiar with cloud and managed Kubernetes clusters, but I think the experience of self-hosting are rare in Taiwan. In this section, we will look at some well-known networking protocols and that you know how to optimize networking performance with those protocols. I hope you find it useful. Before we get started, I'd like to share a little bit about who I am. I'm Jiajun Ye, a software engineer and a system administrator. Recently, I've been focusing on backend development, particularly in financial trading. I also have practical experience in self-hosted Kubernetes administration. I was a CTO and a VP of a startup, and before that, I worked as a backend developer. I'm currently open to new opportunities. If you have any job openings, please feel free to reach out. For more information, such as my resume or LinkedIn profile, you can visit my personal website using the link below. You can also access this presentation there. Since a lot of people couldn't find the slide, if you need to access this slide, just type in xnum.in in your browser and navigate to Explore My Talk button. You will find it. Let's take a look at today's agenda. This presentation is structured as follows. We will begin with a performance evaluation of different networking setups. Then I'd like to share my experience of encountering BGP for the first time. After that, I will provide some background knowledge and the basic concepts. More importantly, I will demonstrate the benefits we can gain and the challenges we may face. And finally, I will share my takeaways from this journey. So, since we are talking performance here, I'd like to start by showing you the result. For those of you who don't know much about CNI, let me explain it first. CNI stands for Container Networking Interface. In an on-premises cluster, you need to install CNI plugins to provide networking functionality. Later, I will mention some well-known CNI plugins such as Calico, Funnel, and Cilium. Back to the topic. I found a research study comparing different CNI plugins to understand their performance. It evaluates TCP throughput for different CNI plugins. All running in tunnel mode get similar results. However, direct routing mode caught my eye. As you can see from the chart, the direct routing mode of Calico has blazing fast performance compared to others. It's significant from 1500 MTU to 1600 MTU. I also found another research study comparing TCP latency between CNI plugins. Besides part-to-part communication on the same node, Calico in underlay mode performs the best. These two studies suggest that deploying Calico in underlay mode probably provides the best performance for our cluster. Our goal today is to understand the difference between tunnel mode and the direct routing mode, as well as what underlay mode is. First, let me explain how these concepts came to my attention. I remember when I set up Kubernetes for the first time, I discovered that we needed to install a CNI plugin. While reading the documentation, I found various networking options to adapt to different situations. At that time, I wasn't familiar with BGP, so I just copied and passed the one-line installation command. Many people might have done the same, installing CNI plugin using the official YAML file without any changes. Doing so makes the cluster work, but it also means we miss the opportunity to optimize it. Over time, I noticed that BGP is mentioned frequently, such as in MetalLB. It has both Layer 2 and BGP modes. Again, I just took the default settings to make the cluster work. Like many developers, most people just want it to work and don't worry about the fundamentals. But I knew I had to understand these concepts eventually. So let me share what I've learned along the way. While setting a Kubernetes cluster, you have to determine the pod CIDR and the service CIDR. Both are IP subnets for internal communication. And Kubernetes assigns these IPs to pods and services. With that established, let's consider the networking modes. Networking modes can be categorized into underlaid and overlay. Imagine your company has offices in different cities. The physical internet connections and the hardware in each office make up the underlay network. On top of this, you might use a VPN to securely connect all these offices. This way, the Hsinchu office can access an intranet website hosted in the Taipei office. That's the overlay networking. It's virtual and appears seamless to users. The key difference is that underlay networks in those CNI plugins allow direct communication over the physical infrastructure. On the other hand, CNI plugins usually use tunnel technologies like IP/IP or VXLAN to set up overlay networks. If the physical network isn't configured properly, your switch might drop packets from inside the cluster because they don't recognize those IPs. To avoid this issue, we use overlay networking to handle the traffic. In an overlay network, not all traffic goes over the tunnel. This may explain why Calico isn't the best one in all benchmarks. If you still remember, when running an overlay network, communication within the same node actually performs better than in an underlay network. Most traffic in a Kubernetes cluster is a pod-to-pod communication. It can be categorized into two types, inner traffic and outer traffic. Let's take a look at this graph to understand the difference between inner traffic and outer traffic. The green line represents inner traffic, where two pods communicate via the Linux kernel. The red line represents outer traffic. Originally, the switch transfers the traffic to an incorrect place because it can recognize the pod IP. To make it work, two funnel daemons established an IP/IP tunnel. Now, let's delve deeper into IP/IP tunneling. You can imagine it as an international carrier service delivering parcels across countries. Path traffic between nodes is like global delivery, requiring import and export procedures similar to customs. Once the parcel reaches its destination country, it's handed over to a local delivery service to reach the final recipient. This mirrors how data is transferred to the target device. The encapsulated packet is unwrapped, and the inner IP packet is delivered to the pod. This process ensures that the packet reaches its destination without getting lost or misrouted, similar to how a parcel is correctly delivered to its final address after being handed over by the internal courier. Back to the topic. We need path traffic between nodes to behave like node-to-node traffic. With tunneling, all IP packets are encapsulated into another IP packet. The outer IP is the node IP, and the inner IP is the pod IP. Now that we have a big picture of overlay mode, it leads us to the question, how do we make it wrong in underlay mode? It brings us neatly to our next point, BGP. I'd like to give you an overview of BGP. It's a commonly used protocol and the key point of this presentation. You can imagine that the internet is a worldwide metro for networking packets. We don't have a centralized organization to build the infrastructure. Instead, internet service providers build it. Essentially, an internet service provider stands for an autonomous system. So every internet service provider is a metro station. And they only know their neighbors' information. For example, if you want to go north, take the train at platform 1, and for south, use platform 2. Repeatedly at every station, you may reach your destination. Unfortunately, the information isn't fixed. Accidents or physical infrastructure maintenance may change or break connections from time to time. BGP comes to the rescue. It allows neighbors to exchange information that will keep the system working automatically. You can also use BGP inside your internal network, just like private IP addresses. So, now we know that we have to let two routers exchange information. That's the only way to make the inner network and outer network aware of each other. But what's the information they need to share exactly? The answer is the routing table. Before talking about the routing table, I first want to describe what routing is. I hope this will help everyone grasp the concept. If you have two computers under the same subnet and the same switch, they can communicate directly without a router. But if they are in a different subnets, they will need a router and the correct configuration. These configurations contain two parts, the interface and the routing table. Let's take a look at an example of a routing table. In a routing table, the destination is where the packet is expected to go. If there are no specific rules, they will take the default gateway. The gateway is the neighbor that this router is connected to. It's an exit for the packet. So if you don't have any configurations, packets from the inner network will be sent to the default gateway. As we already know, these packets will be simply dropped because the internet won't allow any private packets. The final concept is equal cost multi-path routing. If we have several paths to one destination, we can send packets to different gateways. To enable this feature, there are 2 key points. First, after routing calculation, we need to find that more than one gateway is desirable. Second, we have the pick-10 algorithm to select a gateway. Those algorithms usually use the source IP address and or destination IP address as input. They determine the gateway through a hashing procedure. This way, one gateway can distribute the traffic to all available routes. They could make the whole network more efficient and reliable. Building on this idea, let's see what benefits we can gain from these features. After configuring Calico to run in BGP mode, we noticed that our physical switch now obtains routes for the pod CIDR. As you can see in the entry 1 and 2. The next hop is the node's IP address, and the subnet is assigned to that node. It also obtains routes of service CIDR, so now, if we need to access a service, you may not have to use port forwarding. Also, route entry 4 and 6 come with ECMP. It provides 2 gateways to serve the traffic for the same destination. Next, let's see what Metal LB can do in BGP mode. I've summarized this from the documentation. When Metal LB runs in layer 2 mode, only one node can serve all traffic. If that node goes offline, another node takes over. So it's a failover rather than load balancing. On the other hand, when Metal LB runs in BGP mode, it informs the switch that we have several nodes, and all these nodes can serve traffic. This behavior is more like load balancing. I've also come across some great info on BGP mode in CDNAM's documentation. It turns out that running CDNAM in BGP mode can bring the same advanced networking benefits as Calico and Metal LB. First off, it provided true load balancing. This means it effectively distributes network traffic across pods and nodes, ensuring that resources are used optimally and no single part of your cluster gets overwhelmed. Additionally, it enhances network performance. CDNAM leverages the standard neatness routing table, which allows it to cooperate seamlessly with your underlying network infrastructure. This results in better performance without the need for complex configurations. So, by running CDNAM BGP mode, you can really boost your cluster's networking capabilities with advanced net load balancing and optimized performance. We will discuss the benefits. Now let's explore the challenges you may need to overcome. If you ask me, I would say knowledge is power. You definitely have to learn and master that kind of networking knowledge. Understanding these concepts is the most important part. Make sure you know how it works and why it works. There's not much room for trial and error. Also, do some experiments with basic cases and simulate more complicated scenarios. This will help you learn more. You might think it works a certain way, but that doesn't mean it actually does. Next challenge is a potential issue. When the number of nodes grows, the entries in the routing table and the ARP table will grow as well. But these entries usually have a limitation, and too many entries may cause a performance issue. To deal with this problem, you may need a more complicated networking design. If you are interested in this topic, take a look at this article from trip.com. Another notable challenge to be aware of is the limitations of ECMP and BGP. BGP-based load balancing doesn't handle changes in the backend IP set very well. When a cluster node goes down, all active connections might break. Also, if there's an invalid route entry in BGP, it might take a while to remove it, depending on the hold timer setting. This can cause connections to become unresponsive for a short time. Using a more stable ECMP hashing algorithm can help with this issue. It's crucial to understand these limitations to keep your network strong and reliable. Alright, let's wrap things up. Diving into networking concepts can really help you unlock the full potential of Kubernetes CNI plugins. This knowledge lets you optimize networking performance and improving system reliability. While setting up CI plugins might seem complex at first, spending time to thoroughly understand the documentation is worth it. It will not only boost your network's efficiency, but also make managing your Kubernetes environment smoother. So don't just jump straight into installation and copy-pasting commands. Take the time to read through the documentation carefully. Knowing the limitations of your current setup is crucial for troubleshooting and avoid potential issues down the road. If you don't mind, I'd like to leave questions until the end of my talk. Feel free to ask anything. Thank you for your attention, and I hope you found this talk helpful.
只超时一点点。好，这个现场有没有要 Q&A 的啊？那个考网络啊，就是我每天的工作，在看网络的。我们就 Q&A Q&A， 我们用 overrun。
那就是你有试过用那个 BFD 加上 BGP， 然后来解决刚刚那个就是 withdraw 太长的问题吗？
说 BFP 加 BFD。BFD。
Bidirectional forwarding。
没有，我们就让它这样，因为在我们的状况地端的话 ，IP 不会经常变更。我需要用英文讲嘛，就是 on premises environment。Our node wouldn't change frequently, so maybe.
但是如果就是 node 死掉的话，那条 route 就会变 invalid。
对，但机会真的很小，因为地端环境里面就是那机器死掉，我们可以预先知道。
OK。
比方说它就是要 maintenance， 要当掉，那我们就会选一个比较 OK 的时间去做，所以就这件事情没有特别去 optimize。
你应该在讲收敛问题嘛，对不对？
Node 不预期的 shutdown 的时候会造成问题嘛？假如今天是预期的，就是我先做了 code and drain， 然后 Node 是那个 CNI 会自动知道这个 Node 被 code， 然后把它宣告拿掉嘛，把它从 BGP 宣告拿掉。还是要做其他动作，就是如果导入这个的 BGP 的话。
这件事我不确定，因为我没有试过。
好，谢谢。
想请教一下，为什么它会使用那个比较属于外部的 BGP，而不是比较属于内部的 IGP，像是 OSPF？
比较外部跟比较内部的。
像是在做 routing protocol 的话 ，BGP 是比较属于说我要跟一些不是我管的网路做 routing，会使用 BGP 类型的像 BGP。那如果说我今天是例如说在同一个 AS 内的，那我当然就会用 OSPF。
其实也没有特别为什么，因为这些 CNI plugins 它支援的话，它就会说他们会 support BGP 这个 setup 的方式。所以基本上顺着它用啊，也不是说我想用什么就用什么。
那它会去干扰到外部的 BGP 的连线？
不会啊，因为你们要互相连线啊，而且有 private 的 ASN 啊，基本上是不会。
如果说我刚好那个 networking 它也有在跑其他的外部的
那个 networking， 但是这样很吊诡，是因为你的宽频跟你的 OOB manage network 连在一起，就正常来讲应该是会切开吧，是这样吗？应该说，在你平常那个网络上面 VLAN 切开之后，然后你要说在那个 interface 去起那个 BGP 的那个 service， 好像对 Switch 来讲也是蛮奇怪的一件事情。
你们等下，因为刚好我从外面做到里面，全部都做过，所以你们在讲里面，你在讲外面，然后你讲的比较偏外面，你也是讲的比较偏外面，你们刚好范围不太一样。我统一回答 BGP 那个 router 是会影响的，但现行的 那个 IGP 的定义，在现行 Cloud Native， 也不是说 Cloud Native， 现行都比较偏多 BGP 为主 ，OSPF 已经很少看到。我最近才被问说，可不可以在 Cloud 上面盖 OSPF， 我就直接说不建议，就直接说现在做 BGP、IBGP 全部建起来就对了。对。然后你都忘记什么题目了，反正就大概是好像 BFD 现在已经快叫做他们叫做一定要用啊，就是现行全部都 BFD。对，我们现在都有被要求，全部都要做 BFD 的那个 link detection 这样子。对，就 failover 的时候啊，因为他现在都会被要求在1秒内要做那个 failover， 那个 BGP 的时候，那个 timer 你设10、30那个都太久了，那个动没掉。对。但我要回答他的问题。
塔利考有写一篇文章说他为什么选 BGP， 好，他的原因是因为 IGP 的话，这种任何 protocol 都必须要知道说你 IGP 上面的电流是什么。对，因为 AS 它预设就我不知道你在干嘛。对。好，结束。
好，
你可以去看。
看起来我们 networking 明年可以再单独一轨出来，没想我好 OK， 谢谢。很好。我想说，谢谢。